Hello students, today in this video we are going to discuss about another topic of laws of motion. The topic name is particle moving in an inclined plane. Already you have studied equation of motion in straight line, laws of motion, and 3 laws of motion given by Newton's. Now we are going to find out motion in inclined plane by using the Newton laws. Okay, let us consider a body of mass m, which is placed on inclined surface. Make an angle theta with respect to the surface. So this is the theta. A body of mass m placed on inclined surface. The inclined surface is frictionless. That means smooth body. If mass of the body placed on the inclined surface has to be accelerated towards downward, that means along this direction. So the body has to be accelerated. This is length. This is A. A represents inclined surface length. So the bottom of the length is L. So this is height of the inclined surface. But our aim to calculate the acceleration of the body along the surface, and also what is the velocity of the body when it reaches at the bottom. First one is acceleration of the object, velocity of the object when it reaches at bottom. These two things now we are going to deal. Body has to be moving along the surface, which is inclined with respect to the surface. What is the acceleration of the object along this surface, and also what is the final velocity when it reaches the body. Before going to calculate these two things, we must remember two important things. That is a free body diagram, FBD. What is FBD? Already you have learned. FBD, it is a simple tool, or it is one of the tools to analyze about motion of any object by using the Newton laws. By using the FBD diagram, now we are going to deal these two things. Okay. If you want to use the FBD diagram, that's a free body diagram. So we have to analyze the two important things. See, before going to draw the FBD, we have to develop some concept. What are the concepts to be developed? First concept, one is, if whatever size of the body, whether the big size or small size, consider as a point mass. First one is, any size of the object, always consider as a point mass. Second one, how many forces acting on the body? So the forces acting on the body. The next, third one is, force must be expressed in the vector form. Vector form. So these are the three things must be follow when you are using free body diagram. So these are the important things. First one is, any size of the object must be considered as a point mass. Second one is, what are the forces acting on the body. The third one is, the force must be represented by the vector. So these are three things. Okay. First draw the APD diagram for this point mass. Okay, let us consider whatever may be the size of the body, consider as a point mass. This is the point mass. First, point mass. How many forces acting on the body? For this body, there are two forces acting. One is due to gravitational force, due to gravitational. F suffix G. So, force due to gravitational. Another one is normal force acting on the surface. That is a F. So, for in this body, one of the force. So, that is a gravitational force, F. Another one is normal force acting on the body. So, the body is considered the point mass. So, the two forces acting. Here you must consider the two forces acting on the body. Another one more important things. Force acting on the body must be considered in this case. If force extended by the body should not consider. So, first one is only the how many forces acting on the body. External force must be considered. The force extended by the body should not consider. So, the important things. So, the two forces acting. Okay, let us consider another one more diagram in a simple manner. This is the point mass, incline in the surface, which is very smooth. One of the force acting downwards, that is mg, that's a force due to gravitation. Another force, normal force acting, that is called normal reaction force. Before going to find out these two things, we must consider about the coordinate axis, coordination system. So this is x-axis, this is the y-axis. X along the inclined surface. This is y, the perpendicular surface. The point mass acting gravitational force toward downward direction mg. This is the normal reaction. Normal reaction force. Here, the gravitational force acting toward downward direction has been resolved into two components. So, the gravitational force acting toward downward direction, that's a gravitation always acting toward downward direction, has to be resolved into two components. So, the force has to be resolved into two components. The two components always must be perpendicular to one another. One of the force along the direction of the object where it moves from the top to bottom. Another one is a perpendicular. There are two forces. These two forces are perpendicular to one another. So, mg, gravitational force acting downward direction, has been resolved into two components. One is along the direction of surface where it moves. One is a perpendicular to the direction where it moves. So, the two things, the two forces are perpendicular, but they are not equal, but perpendicular. Mg has been resolved two components. One is a perpendicular direction, another one is a parallel. Along the direction of inclined surface, another is a perpendicular direction of inclined surface. Okay, how to resolve? See, the mg, that force mg, gravitational force, which is making angle theta with perpendicular force of the slide, perpendicular force on inclined surface. So the theta, this theta is the angle between gravitational force and the perpendicular force from the surface of where it slides. This theta, both are equal. How to calculate? How these two forces, how these two angles are equal? With mathematically, we can express. So this is the point mass. This is mg acting perpendicular. This is normal force. This force, this is perpendicular. This is the theta. This is the theta. This is the theta 1. This is the theta 2. Suppose it is A, B, C, D, E. The triangle, right angle triangle A, B, C, it's a 90 degree. It's a right angle triangle. So in ABC 90 plus this theta plus this theta 1 is equal to 180 degree. We know that. Right angle triangle ABC 90 plus theta 1 is equal to 180 degree. We have to calculate theta 1. Suppose theta 1 is equal to 180 minus 90 plus theta. 180 minus theta, 90. So 90 minus theta. So this is the theta 1. In this case, this is a D, this is a E. So E and D are perpendicular to one another because two forces are acting perpendicular to one another. So it is theta 1 and theta 2. Theta 1 plus theta 2 is equal to 90 degree. Theta 1 plus theta 2 is equal to 90 degree. Here the theta 1 or theta 2, anyone, theta 2 is equal to 90 minus theta 1. Already we proved theta 1 is equal to 90 minus theta. So theta 2 is equal to 90 minus theta. So 90 minus theta plus theta, 90 cancel. So theta 2 is equal to theta. So these two angles, the angle between the gravitational force and the perpendicular component with respect to the surface, this surface equal to the inclined surface making angle theta with respect to the ground. So this theta which is equal to this theta. We proved that. Okay. But our aim to calculate the acceleration of the object. What is the acceleration of the object? If the body is a place in this position, now is sliding toward downward direction. But throughout the body, throughout the distance, the acceleration remains constant. Always constant. Acceleration from this point to this point, the acceleration remains constant. First, we have to calculate the acceleration by using the free body diagram. Okay. Now, this mg has been resolved into two components. This theta make an angle with the perpendicular. If it is a theta, the horizontal component is always cos angle. This is a vertical component is always sine component. So this is mg sine theta. This one is mg cos theta. So opposite of the theta is perpendicular. That's mg sine theta. This is a horizontal. It is a cos angle. So mg has been resolved the two perpendicular component. One is mg sine theta and mg cos theta. So mg sine theta acting along the inclined surface. Mg cos theta perpendicular to the inclined surface. Okay. Now, let's see. This is a body. This is a body neither move upward direction nor downward direction. So no force acting on the body by normal force and also mg cos theta. So these two forces are equal. A body, it does not move upward direction, but it has to be slide toward downward direction. But this neither move upward direction nor moving downward direction. So the force, no acceleration acting at the point by this normal force and mg cos theta. So n is acting along positive y-axis, mg cos theta acting along the negative axis. So the two forces are balanced. So n j cap means along positive axis, then plus mg cos theta minus j cap is equal to 0. Why? The body m neither move upward direction nor move downward direction, so remain stationary. So n j cap plus mg cos theta minus j cap is equal to 0, or n j cap minus mg cos theta j cap is equal to 0 because minus. So n j cap is equal to mg cos theta j cap. J cap cancel. So n is equal to mg cos theta. The normal force is always equal to mg cos theta. So the body does not move upward direction and also downward direction. Neither move upward nor move downward direction, but has to be accelerated toward only the direction along the vertically. So this no acceleration. So A acceleration along y-axis. The body is oscillated only along x-axis. Here n which is equal to mg cos theta. Now body has to be oscillated towards only downward direction. So mg sin theta. Now the body is moving toward downward direction. So the body accelerated from this point to this point. Only the oscillation along x-axis. Oscillation along x-axis. Let's consider, remember once again, the surface is frictionless surface, a smooth body. No force is acting upward direction to balance this force. The body is continuously slide down. No force acting upward direction. So the force becomes zero. If the body is moving, if suppose the surface is friction, it has friction, the friction force acting upward direction. So completely smooth. So the force acting only the downward. The body is moving only the downward direction. The body accelerated downward. So F is equal to mg sin theta. This force is equal to mg sin theta. So F is equal to ma mg sin theta along x-axis. I cap. Only positive x-axis. So F is equal to mg sin theta. No force acting upward direction. If the force is there, there would be the balance by the mg sin theta. That's why the body slide down. Continuously slide down when it reaches the bottom. No force acting in the bottom. So force F is equal to mg sin theta. So F is, we know that from the Newton's second law. F is equal to ma, mg sin theta, m cancel. So A is equal to g sin theta. A is equal to g sin theta. This is the formula to calculate acceleration of object when slide on the smooth surface. When inclined with respect to the ground, when any body is moving along the inclined surface, could be calculated by using the formula A is equal to g sin theta. This is important. Acceleration on inclined surface or which is nothing but inclined surface. So the next one is, what is the velocity of the object when it reaches the bottom? The body continues its slides with a constant acceleration when it reaches the bottom. When it reaches the bottom, what is the velocity? How to calculate the velocity? The velocity should be calculated from the formulas. Which formula? From using the Newton's formula, straight line equation. What are the straight line equation? First one is V is equal to U plus 8. Second one, V square is equal to U square plus 2AS. Third one is equal to S is equal to UT plus half AT square. From these three formulas, we have to select any one. Your body is continuously moving in slide down. So the velocity when it reaches the bottom, we have to calculate. From these three formulas, among these three, which one is suitable? First one is V is equal to U plus AT. Initial velocity, final velocity, acceleration, time. But we are not considering the time factor. So it is not possible. Okay, the V square is equal to U square plus 2AS. What is the V? V is the final velocity when it reaches the bottom. U, initial velocity. When it's a place on the smooth surface, it starts to slide down. So the initial velocity, we are not giving any external force, that is from the outside. So initial velocity remain 0. And two constant, A, acceleration of the particle, A, distance where it moves from initial to end. That's a distance. So it is a suitable. And third one is S is equal to ut plus half at square. Here also the time factor comes. So these two formulas not suitable to calculate the velocity of the body, and the second one is suitable. So v square is equal to u square plus 2as. So v square is equal to u square plus 2as to calculate the velocity. To calculate the velocity. This one is acceleration. Calculate the acceleration. Acceleration of the body. To calculate the velocity. From this, select the formula. V square is equal to u square plus 2as. Okay. What is a v? V is a final velocity. When start here and reaches the bottom. When it reaches the bottom, the body does not move anywhere. So velocity v square. But what is a u? U is the initial velocity. But we are not giving any initial velocity on the body to slide down. So initial velocity remains 0. 2. A. What is a A? A is acceleration. Throughout the distance, the acceleration remains constant. A is equal to, that is g sin theta into s. So v square is equal to 2g sin theta into s. But v is equal to root of 2g sin theta into s. This is the formula to calculate the velocity of the body when it reaches the bottom. Okay. Two important things must be remembered. If any body is a place, smooth surface which is making certain angle with respect to the ground, the acceleration could be calculated by using the formula A is equal to g sin theta. G represents acceleration due to gravity. So generally the average velocity on the surface of the earth is g taken as 9.8 meter per second square. But sometimes in mathematical calculation, the question itself is given, take g is equal to 10 meter per second square, there use only the 10. If the 10 meter per second square not given, you always by default use 9.8 meter per second square. Okay. So A is equal to g sin theta and the velocity v is equal to 2g sin theta. From this equation, we conclude velocity of the body and as well as acceleration of the body highly depending upon only the angle. Acceleration A is equal to g sin theta. Okay, the v is equal to 2g sin theta and also the displacement. But g sin theta, g always constant. Suppose for that place g is a constant, theta. If the theta changes, acceleration also changes. For in this place, acceleration remain constant. So A depending upon only the angle theta. Okay. Now let us consider one more thing. There are two different angles. Suppose this angle is 30 degree. This one is 45 degree. There are two inclined smooth surface. Your body, your mass 1 kilogram, and also the same 1 kg place. In which inclined surface acceleration more. And also another one more example I will give you. Suppose this is almost perpendicular, it's not inclined. Okay, let's take only the two things. There are two different angles. One is a 30 degree, another one is a 45 degree. So the inclined surface make an angle with respect to the ground. 30 degree, another one is a 45 degree. In two cases, first one, it is a second one. Which inclined surface the body which get more acceleration. How to calculate? By using the formula. A is equal to G sin theta. If where the theta is greater, A is equal to greater. So A directly proportional to sin theta, because A, G remain constant everywhere, but that given instant place. So A is equal to G sin theta, the theta is greater, acceleration due to gravity also the greater. Suppose the first one, second one. In first case 30 degree, second case 45 degree. In first case, A is equal to G sin 30 degree, first case. In second case, A is equal to G sin 45 degree. Take G is equal to 9.8 or 10 anyone. So 9.8 into sin 30 is 1 by 2. So 4.9 meter per second square in first case. First case. In second case, A is equal to G sin theta. A G 9.8 into sin 45 1 by root 2. We know that 1 by root 2 is always equal to 0.707. So A, it is better it is take 10. It is easy to clear. 10 by 2 the 5 meter per second square. 10 into 0.707. So 1 by 2 the factor root 2 value 1.414. If we divide 1 by 1.414, we will get 0.707. Always you remember in mathematically. 1 by root 2 is 0.707. If you multiply 0.707, it is 7.07 meter per second square. See the two cases. If the angle is 30 degree, acceleration of the body which is slide down in one of the inclination surfaces 5 meter per second square. In the second case 7.07 meter per second square. From that we can conclude where the angle is more, the acceleration of the object is also the greater. So acceleration of the object or any body highly depending upon the angle. So when the theta is greater, angle of the acceleration of the object is also greater. And also we can calculate the velocity. Velocity also we can calculate. 2 G10 sin 30 1 by 2. Suppose yes, for example, a body of mass 1 kg of mass is placed on the surface. 1 kilogram of mass placed on the surface of the inclined surface. Make an angle theta with respect to the surface, that is a 30 degree. The distance move at about 10 meter. What is the velocity? What is the acceleration? What is the velocity? We have to calculate two things. First one is the mass of the body, m given 1 kilogram of body, 1 kg of mass, placed on the inclined surface. Make an angle 30 degree with respect to the theta with the surface. Theta is equal to 30 degree. Theta is equal to 30 degree. The mass 1 kg placed in inclined surface, make an angle theta with respect to the surface whose value is, whose angle is 30 degree, which distance cover from this point to this point, that is a S, 10 meter. So S is equal to 10 meter. Where acceleration due to gravity take G is equal to 10 meter per second square. Now calculate the two things. One is acceleration, another one is velocity. What is the acceleration? Acceleration A is equal to G sin theta. So A is equal to G sin theta. G take 10, sin theta 1 by sin 30. Sin 30, 10 into 1 by 2 is 5 meter per second square acceleration. Okay. Next one is a velocity. How to calculate the velocity? Velocity formula V is equal to 2G sin theta. So V is equal to root of 2G 10. Take G is at 10. 10 already given. G value given. If the G value is not given, consider is always 9.8 meter per second square. So the G given. Sin theta, sin 30 into S 10 meter. Root 2 into 10 sin theta 1 by 2 into 10. 5. 5 tens are 50, 52s are 100, or 2 to cancel, 100. That's a V. If V is equal to 10 meter per second, velocity. By using this formula, we can easily calculate what is the acceleration of the object and what is the velocity of the object when it reaches the bottom, when on the inclined surface. This activity can be used if any object is loading, unloading on the lorry and buses, any automobiles. By using this formula, we can calculate how to slide the object, what is the velocity of the object when it reaches the ground. So I always keep in our mind. So these are the basic formula to solve the problem in further topics. So acceleration on inclined surface always A is equal to G sin theta, and velocity of the body when it reaches the ground, V is equal to root of 2G sin theta into S. So by using this formula, we can find out the velocity and as well as the acceleration. In this video, by using the free body diagram, we calculated the acceleration of object when it slides on the smooth surface, and also velocity of the object when it reaches the bottom. So the next class we will study another topic. Thank you.